Okay, everybody hears me, good. So what we're doing is we are taking our experience from the Vert.x team working on reactive things and trying to influence the MicroProfile specification because there is a strong interest into embracing reactive in the specification, and eventually in the future, this will also influence the JakartaEE, which is the new JavaEE specification and evolution for the future. But before we go a bit further, let's look back into in time. So just to put things in perspective, here's a timeline from 2007 to today. On the bottom, you can see that JavaEE has been slowly evolving. We didn't have that many releases given over 10 years, only 3 actually. And meanwhile, in the world, many things have changed. So we've moved to, we have technologies that we use today like Node, Kafka, Vert.x, Docker, the Reactive Manifesto, obviously. All these microservices approaches, deployment to Kubernetes, etc. So the world is moving fast, and meanwhile, what has happened is that JavaEE has been very slow to evolve, and it kind of stayed in the same philosophy and same line.
It seems it's accelerate near the end, right?
Oh yeah, there is MVC.
This new technology.
Yeah,
what is it?
MVC is changing. It's a game changer, right? So clearly, JavaEE it has a fit in the past because it is, while all the cool kids today are looking at event-driven solutions, CQRS, all these things, domain-driven design. The typical use case of JavaEE tends to be mutable CRUD databases. And the development model is stuck with CDI, JAX-RS, transactions. And the execution model is based on the good old servlet specification, where you have one thread processing one request at a time. So clearly, when you think about what we are doing today, and clearly what this conference is doing, the people in this conference, it tends to be something from the past. But there is new hope coming. So when you look at things, clearly JavaEE is not really friendly if you want to go to the cloud, mostly because it used to be based on the assumption you would be deploying to application servers, where you have many applications being co-located within a single operating system process. So it doesn't fit what we're doing today when we deploy to on-premise or hybrid or public clouds, where each service is basically a container, so one process is one instance. And it's not reactive also because in the specs, there is nothing really asynchronous, right? So the asynchronous bits you can find in the specification are the servlets, but good luck if you've been playing with asynchronous servlets. It's not the most friendly thing to use, and eventually down the road, when you do some stuff, you're going to hit some blocking code like the database, so good luck with that. And CDI events, well, that's the other thing you have, which is asynchronous. But it's clearly not enough if you want to embrace the reactive principles. And also, there is no stream support, and it's clear that we need streaming for data processing, and there is no back pressure except thread being blocking, right? So there is new hope because before JavaEE started to move a bit more than the MicroProfile specification was done and incubated at the Eclipse Foundation. So here we have a bunch of specifications to help make microservice-friendly applications or services based on the well-known JavaEE programming models. And it's the good thing is MicroProfile is evolving in a very iterative and fast fashion. And there is clearly now some growing interest into reactive, so this is also why we're here. And in the long term, so now JavaEE has been freed from its previous place. So JavaEE is now called JakartaEE at the Eclipse Foundation, and it's going to evolve much faster and possibly embrace reactive in the future. So Thomas, can you talk to us about reactive and MicroProfile?
Sure, Julien. So a lot have happened over the last 6 months in the reactive MicroProfile working group. It has produced 3 key new specs, the reactive streams operators, reactive messaging, and concurrency. Also, they have been looking at bringing reactive to JakartaEE, so the specification to build RESTful services. And a lot more are to come. We also have something in service mesh and fault tolerance, I think, and also a more high-level web client.
Sure.
And this happened, it was a lot of effort because many companies have interest in that. Reactive is a hot topic, so it's not only one company in the JavaEE ecosystem, it's many of them, and especially Lightbend and Red Hat, who have been working hard in the reactive MicroProfile specification. So Lightbend is more looking at bringing implementations of the spec with Akka, and at Red Hat we are more looking at implementations with Vert.x. So enough with the usual list of specification. Let's look at it in practice. So here you have a classical programming model with annotations, and you define a web service with JakartaEE. And what's different is that usually when you create a method with JakartaEE, once the method finishes execution, the response is sent back to the client. And here we have a reactive streams publisher. And since the runtime will notice that we will use the server-sent event content type, it will use that producer to send events to the client. Okay, so the connection is not going to end when the method is finished. Another example of the specs, the reactive messaging one. So we can connect different channels, so to speak, or incoming messages and outgoing messages. So it's a simple example when you want to filter a stream. So here we have some health information about a living animal, and we'll extract just the heartbeat information and send it back to another channel by just adding two annotations for the incoming message channel name and the outgoing message channel. And since we want to publish it to different consumers, we will use the multicast annotation. So that's something the typical JavaEE programmers are used to. A more advanced example, in the previous one, we didn't say anything about the type of messaging system we are targeting, but we can deal with different types of messaging system. Kafka is just an example, but it could be ActiveMQ or any other. Which are supported, of course, but we'll come back to that later. So this is not in the spec already, but since different messaging systems have different semantics, we will have probably more annotations, to deal with the different semantics. In particular, in this example, it's acknowledgement of the messages. So again, this is not in the spec yet, but it will come pretty fast. Last one example, reactive streams operators. You know, of course, that the reactive streams specification does not come with anything else but back pressure management. So we need something, operators, to being able to build our streams. So here the good thing is that Java developers, they already know that kind of APIs, map, flat map, filter. They are used to the JavaEE stream APIs. So it's really not something complicated for this ecosystem. And we can use it. So again, we have different implementation of this spec. And let's see how it works in practice. Yeah.
So the demo we're going to do, they are based on, it's kind of Fitbit for rabbits. And I swear no rabbit were harmed. Only Clément's rabbit was harmed. So, so we have a demo in 5 steps. So we are, oops, wrong place. So we're going to start with something simple. We're going to show you JakartaEE based on REST-easy, pushing server-send events to the browser. So something very simple where we will see whether the rabbit is sleeping, awake, or eating. And this will be all done through server-send events. So in this project, here is a typical JavaEE resource, right? It's called Neo. So Neo is the name of Clément's rabbit. And yeah, it's a typical application scope bin that you would find in JavaEE. So again, it's really the good old JavaEE component-based model. And there is a state method, which is giving you a reactive streams publisher. So this is where you will get, well, you can subscribe to get the events. And basically, all it does is every 3 seconds, is going to cycle through whether the rabbit is sleeping, awake, or eating, right? And the JakartaEE results, which is here, so it's very typical JakartaEE, just as you would do to expose some HTTP API. So you inject that bin, right? And the only thing which is different from what JavaEE developers could be used to is that you have a new media type, which is server-sent events. I will show you in a minute how it works. And the thing is, you return a publisher. So because you return a publisher, then there will be a subscription, and all the events will flow to the browser using server-sent events. Okay? So it's pretty simple. If I try to run this thing.
So you're going to start an application server?
No, Thomas. I'm not going to do that. There is no need to use an application server. So I'm just starting a plain old executable fat jar, as we call it.
2018, cool.
Yeah, well, you could even use something else. And then, so it's going to be on localhost on this. And we have the web interface, and Neo is going to change. So Neo is sleeping, Neo is awake, etc.
Rabbits are not very fancy animals, you know. They don't do a lot of things.
So what could be interesting is, so if I get back to my IDE, I see that on the /neo path, I have that resource of server-sent events. So I'm going to take another tab here, and I'm going to see what happens. So it's on port 9, this one, /neo. And since it's a stream, I'm going to follow what's happening. And you see that this is the server-sent events protocol is fairly simple. It's just events that flow as text. And it's a very simple way for the backend to push to the front end. So nothing too fancy. The lesson here is that we went from JakartaEE to JakartaEE that sends events using reactive streams. So the next step is we're going to introduce reactive messaging. So the difference is that now we are going to have a bin which will produce health data. So health data is going to be the temperature of the rabbit, the heartbeat, and the blood pressure. And we will have a processor bin in the middle using reactive messaging that would take the health data and filter just to push only the heartbeat to the browser. And this is an illustration of reactive messaging. Yeah. So my demo is here. So that's my bin, right? So this bin is just, again, a good old JavaEE bin. And there is a method called health here that's been annotated with outgoing. So it means that it's going to produce messages to the health destination. And what health mean as a destination for messaging, then it depends. It can be Kafka, MQTT, or just something in memory like like in this case. So what we're doing is we're just pushing periodic data, and then it's going to be processed. So
here, if I don't specify anything, it will be just memory.
Yeah.
Okay.
If we don't have configuration, and we'll come to that when we introduce message brokering, it's just in memory.
Okay.
So I can consume message, and I can produce messages. So you have it here, like I'm going to consume what's coming from health. I'm going to push that as heartbeat to some destination called heartbeat. And what I'm doing is that I'm taking a JSON object as an input, and I'm going to push only the heartbeat value. Okay? And on the JakartaEE side, I have a new resource called bit. And again, it's a publisher of JSON data, and it's going to push JSON data to the front end. So same thing as before. If I try to run that, there is no application server, although it's JavaEE programming model. So I'm going to run that. So I have now a new tab with the heartbeats. So we're going to see whether the Neo is doing anything. Is he died? No, he's sleeping. No. So he's sleeping.
He loves that.
So we can see the heartbeat, and the heartbeat results. Do you remember, Thomas? Is /bit, right? Yeah.
Yes.
/bit. So just to see that you can stream JSON data as server-side events. So it's bit /bit, and we see some JSON, right? So again, you have something very simple to use to integrate the front and the back in a purely reactive fashion. You're just streaming messages between the two, okay? So what else can we do? Well, it's still a long road ahead.
Yeah, if we want to make a full fast data platform, we need
we need a
more
bit
advanced.
Yeah. So now we're going to use reactive streams operators. And to do that, so the filtering of the processor is going to be made with these operators. So we are going to use some operators. And then the other thing is we are going to talk to another service. So there will be an endpoint called Snapshot Service. All it does is it will take the last seen value of the rabbit data. Okay, so it's just a service. We will post the JSON data, and it will just record the last.
Like an auditing service. Yeah.
Like
more
an auditing
businessy.
service. Yeah,
we are JavaEE developers.
Yeah, something like this. And we will compose basically that HTTP request, which is going to be asynchronous, and then filtering the data to produce the heartbeat. So it's probably clearer if you see the code, I think. So just for the record, the Snapshot service is a plain Google JAX service endpoint. So when you receive some JSON here through an HTTP post, then you just store the latest values as fields, and then you expose sub-resources for each kind of data. It could be interesting, like temperature, heartbeat, etc. So there's nothing too fancy here. The processor is where we have more things to do. So it's using the Vert.x HTTP client, which is non-blocking and purely asynchronous. So it's issuing an HTTP post to that snapshot endpoint, returning some reactive.
As Vert.x reactive implementation of the spec, or is it you can mix Vert.x APIs with the reactive MicroProfile?
So you do the
reactive MicroProfiles.
It's a good question, and I swear we didn't prepare that. You can use the completion stage API, which is neutral for specifying asynchronous steps you want to compose. So here I'm just returning a completion stage. So I'm adapting from Vert.x to completion stage, and then the next thing you do is in the chain, so you do that call using flat map completion stage, right? So you're gonna invoke the service, and then once the HTTP request has been processed, what you do is you use map to take the whole health data JSON and only extract the heartbeat.
So if I get it correctly, it's because you can, because it's implemented with reactive streams, you can mix with any other tool that implement the reactive stream as well.
Exactly, you can mix and match. And the other thing is the multicast annotation is important is because you can have many subscribers. So basically many web clients connected. So it takes care of multiple subscribers to your stream. So if I go back to the execution just to show you what it does, demo 3. So what you're going to see is still the rabbit, but now we have the temperature. So the temperature is going to evolve as well in a purely reactive fashion. So, and it does so because we post it to the snapshot service, and then the snapshot service is being used by that piece of dashboard who's connected. It's connecting to that service, not to the web backend that we have here. So far so great. let's move on to more data streaming things. So now what we're going to do is, here we had a bin that was producing events. Now suppose we are doing an actual Fitbit style of application, and we have an MQTT broker to receive incoming messages of health data. So the rabbits are being instrumented for real, and then we will plug it to the rest of the pipeline just as before. So to do that, I'm going to change to demo 4. And for that, I need an MQTT broker. So to run my MQTT Docker, I have Docker Compose. Is it working? OK, it works. Then I'm going to run some process which is called a sensor, which it's a Vert.x application. And it's just going to produce some data to feed to the MQTT.
Simulating the Fitbit.
Yes. Yeah. So it's not the actual Fitbit, but it could be real rabbits jumping all around. And then I'm going to run the same application as I had before using our stack. So if the demo goes out with me, it should work. And it works. Right. So we are fetching all this data from MQTT. So now let's dive into the code to see how it works. So from here, I have a sensor. So it's a plain Vert.x application, and all it does is connecting to MQTT, and periodically is going to publish some artificial measures, right? So the difference is now we have a process that simulates rabbits and sends data to MQTT. And then the health data processor is going to be the same. So we still have incoming health, but now the difference is now we're not consuming from memory, from a bin producing events, but we are consuming from MQTT. So how it works is, in a typical JavaEE fashion, we have a configuration file here that we have to put. And we just say, can you all read, right? So to consume from MQTT, we say that the health topic, so small array messaging is the name of the implementation project. So we say we have Neo is going to be an MQTT messaging source. And then we have some parameters like the host or the port or stuff like this. But basically, there is nothing else to do, right? So we keep the model of saying we're going to react to events on that destination, and then it can be MQTT or something else.
So if I understand correctly, I just have to put the correct implementation for that source or that sink, and then use that configuration file, and I'm done.
Exactly, yeah. Okay. And just use annotations to say how you wire things together.
Okay.
Okay. So far, so good. And the last step in our demo is so here we have the MQTT server, and we have the rest of the application as a single process, as a monolith, if you want to call it like this. The last evolution is to go to fully event-driven and asynchronous microservices. So in this case, we have the MQTT broker, which is a process. The collector service, which is processing events, is going to be an event-driven microservice. It's going to connect to Kafka to send events split by topic. So when the temperature changes, it will push to some temperature topic. It will do some aggregation, like how many steps the rabbit has done. It will do things like, well, we will see. And the other process is going to be the web application. It's going to be standalone and dealing with the web interface. And the snapshot service, it will also be another independent microservice. So moving from one monolith to many microservices. So to run that, it's a bit more involving because I have more processes. I just need to make sure Docker Compose is nice with me. OK, so I need to take it down, otherwise stuff will not work. OK. And it should be this one. So I have, so to run this demo, I need to run Zookeeper, the MQTT broker, and the Kafka server. So a bunch of logs, but it looks like it works. So the first thing I'm going to run is the sensor. So the same process as before, which is connecting to the MQTT broker and publishing some events. The next one is the collector service, right? The next one is, third is the snapshot service, and the last one is the web application. So everything is okay. So we should see many things like, okay, the rabbit is alive, it's moving, and now the good thing is we see the lips of the rabbit. So this is an aggregated query over, I think it's 10-second periods of time or something. So the rabbit is alive, and we are just processing data this way. So if I get back to the code, I'm going to show you how it's done. So the interesting bits are, so just to show you, we have really separated projects. So one microservice is one project. The collector service is where all the fun is, I think. So the health data collector is going to be like this. So we have several methods, and all of these methods are listening to the health destination, which eventually is going to be the MQTT broker. And every message is going to be output. We'll see how it works. So this one is going, for example, to extract the temperature from the data and set that to Kafka to send updates to the temperature. This one is going to extract the heartbeat. So it's doing the same thing, and it's using the reactive stream operators specification. So use map to compose your event processing. It's not worth sending an update when the rabbit hasn't changed its state. So if the rabbit is still sleeping, it's not worth saying, hey, the rabbit is sleeping. Hey, the rabbit is sleeping. So what we do is that we use an operator like distinct until change to say we're not going to emit anything until it has changed. So the rabbit is doing something else. To process the steps, so we're using some operators like window to aggregate some data over a period of 10 seconds, a time span of 10 seconds. And then once you have that, you're going to do the sum, and then you push that as the lips values. So this is how you get these charts, et cetera, et cetera. So the nice thing with that is that you have each method is going to be specialized to doing one kind of processing of events.
So yeah, with a few annotation and in a declarative way, I can get messages from MQTT and then publish to different topics into Kafka, so that if in the future I add a new service, the new service will be able to consume.
Sure.
Already.
Or if you want to do some other kind of processing for the same kind of events, you just add a method to say I'm going to listen to these events and produce something else. Cool. And as you can see here, we're just using Kafka. So to use Kafka as the destination for the output, we just have again to say this destination is going to use Kafka. So it's a configuration file, and that's it. Did I miss anything?
The code is available on GitHub, right?
Yeah, the code.
And I can try, even if I don't have a rabbit, and try to adapt it to my cat, for example.
Yeah, you don't have to buy a rabbit for that. Fair enough. You don't need that. So the rabbit is still moving. Good news. What's next, Thomas? So we have microservices, asynchronous event driven.
Now the ability to let's wrap up. Now we've gone through all the demos. So what we've seen is that we can slowly, but it came slowly, but now it's going a bit faster, and we can infuse some of the reactive technologies into the Jakarta and MicroProfile ecosystems. And for a lot of communities, reactive principles are not a simple thing to grasp. So here we have a model for people doing Jakarta and MicroProfile type of programs to enable them to do some fast data platforms if they want. What you need to know about the implementation from the MicroProfile group is that there is a small RIPE project which is at the Eclipse Foundation, and that's where a lot of effort is done to implement the reactive MicroProfile specification. So it's open and everyone can contribute. In small RIPE, everything is basically Vert.x powered. The JakartaEE reactive improvements, the reactive messaging implementation, which supports right now MQTT, Kafka, Camel, MQP, and the reactive stream operators specification is implemented with Vert.x and RxJava 2. For the roadmap, I can let you read that later, but what you have to keep in mind is that it's not something which will happen in 10 years. It's happening now, and in 4 months it will be GA and available to everyone, but you can already try it with milestone releases.
Shameless plug. So if you want to know more about Vert.x, and the people at Manning will be very happy as they are in this room, you can buy Vert.x in action and MAP, give us a feedback, it's great. If you have some time tonight, we will be at the Montreal Java user group.
2 blocks away.
Yeah, 2 blocks away, so we'll be talking only about Vert.x, and we'll have a DJ mixing software demo as well. So something with music you can play with your phone and interact, and it's great. So yeah, buy the book, thanks. And Q&A, so we will take all your questions. We'll be happy to answer. We have some very nice mugs from Red Hat. I mean, they are really good. Thank you very much. So 1 question equals 1 mug.
The one? Come on, the mugs are nice.
A question.
So, I don't know if this is on. Okay. So I'm in the process of looking at different frameworks as we try to explore reactive. And so one of the downsides right now is I have a traditional Java application, JakartaEE, et cetera. As we're trying to go towards containers, the runtime right now that we've chosen is JBoss image. So I didn't know. I know I saw it a little bit. I don't know what runtime application servers or images are supported with Vert.x.
So if you run these, when you run MicroProfile applications, you're outside of the application server. Although if you really wanted to, you could, but it's not the model which is being pushed.
It's Fontaine.
Yeah, Fontaine, yeah. So if you want something supported, you would be deploying this to something like OpenShift or Kubernetes, but yeah, the clear destination is this kind of containerized environment.
So basically the MicroProfile specification implementation at Red Hat are not deployed inside the JBoss application server. They are in a separate offering which is called Fontaine. So okay. There is a product for that.
But yeah, in any case, the good thing is you keep the programming model. So no matter if you do Fontaine or small RIPE, well, MicroProfile is going to be
they can communicate together. You take one piece and you go with the reactive model which you like. It could be Vert.x as well. Any question? No?
Are you sure? No question? Okay.
Thank you then.
Thank you again. Thank you.